Hey guys, so today we'll be answering the WJEC A-Level Maths sample paper. Okay, let's begin by answering question 1. So the equation given is x squared plus y squared minus 2x plus 6y minus 15 is equal to 0. So the equation of the circle can also be written as x minus a all squared plus y minus b all squared is equal to the radius squared, given that r is equal to the radius. And the centre of the centre of the circle, can be obtained by using a and b in the equation. So in order to simplify the equation of the circle, we will be using the method of completing the square. So let's first begin by grouping the x's and the y's together. So let's group x squared minus 2x together and the y squared plus 6y together, which is equal to 15. So in order to complete the square, let us first do x minus 1, which is a half of minus 2, all squared, minus 1 all squared, plus, let's do complete the square for the y squared plus 6y to obtain y plus 3 all squared minus 3 all squared is equal to 15. X minus 1 squared, x plus 3 squared, and let's put the minus 1 squared and minus 3 squared to one side to obtain minus 1 minus 9, and that is all equal to 15. So now we have x minus 1 all squared, y plus 3 all squared minus 10. Now if we solve that, we have the whole equation equal to 25. Now we can obtain the centre of the circle, which we call A in this question, and the radius. So A in this case is equal to 1, 3, and the radius squared is equal to 25, therefore the radius is equal to 5. Okay, now let's move on to question 1b. So the point C is at 4, minus 7, which lies in the circle C, and the question is asking us to find the equation of the tangent from C at P. So given that we have the circle with a centre of 1, minus 3, and the point P, 4, minus 7, and we know that the radius is equal to 5. So now let's draw the tangent line at the radius. So we know the properties of a tangent at a radius, it creates a right angle. And the question is asking us to find the equation of a tangent. So we know that the equation of a tangent is the same as finding an equation of a line. So from this we can use the important equations or formulas to obtain the equation of the line. This is y minus y1 is equal to m all multiplied by x minus x1, where m is equal to the gradient, and to find the gradient we need to do the change in y all divided by the change in x, given by y2 minus y1 all divided by x2 minus x1. So given these equations, we can now use these to find the tangent. So by using the first equation, we can find the gradient. So the gradient is equal to the change in y over the change in x. So we're going to start by doing -7 take away -3 all over 4 minus 1. This is the same as saying -7 plus 3 all over 3, which is the same as saying -4 all over 3. So now that we obtain the gradient, we can now find the equation of the tangent by using the equation of a line. So y minus y1 is equal to the gradient, which we obtained by -4 all over 3, all multiplied by x minus x1. So now in order to get rid of the fraction, to get rid of the 3, we can multiply 3 by both sides to obtain 3 all multiplied by y minus y1 is equal to -4 all multiplied by x minus x1. So now we can use the coordinate at P as the tangent goes through the line of the tangent line goes through point P, so we can use y1 and x1 by using the coordinates of point P. So if we replace y1 with -7 and we substitute x1 as 4. So now we have 3 all multiplied by y plus 7 is equal to -4 all multiplied by x minus 4. So now if we expand this, we have 3y plus 21 is equal to -4x plus 16, which is the same as saying 4x minus 3y plus 21 plus 21 minus 16 is all equal to 0. So now we have 4x minus 3y plus 5 is equal to 0. And this is the equation of the tangent, which we found. Okay, so before we begin this question, let's review the equation. Sine squared theta plus cos squared theta is equal to 1. This is a really important formula which is going to allow us to answer this question. So we have
this is equivalent to saying 7 sine squared theta plus 1 is equal to 3 minus 3 sine squared
so we know that
theta minus sine theta.
Has sine inside. So
now we have sine squared theta plus 1 minus 3 plus 3 sine squared theta plus sine theta is equal to 0.
Sine squared theta plus 1 is equal to, in order to replace the cos squared theta, we can use the formula above by rearranging it to obtain cos squared theta is equal to 1 minus sine squared theta. So let's replace the cos squared theta below. So now we have 3 multiplied by 1 minus sine squared theta minus sine theta.